Hi, good morning everyone. Our today's session is on clustering. So the agenda for the session is first we'll quickly have an overview of supervised and unsupervised learning, though we have already learned it in our early data mining sessions. And then we will go into the clustering technique, and two prominent techniques are there. One is in hierarchical clustering, and second in a non-hierarchical there is a k-means clustering. So we'll go through both the techniques. So broadly, you know that there are two main types of techniques. One is basically a supervised learning technique, other is unsupervised learning technique. In a supervised learning technique, the target is already defined. Basically, when you have dependent variable and many independent variables, one or more than one independent variables, and you try to analyze between these two, that is called a supervised learning technique, because what you're trying to do is you're trying to analyze the dependent variable with respect to the independent variables. Simple example, linear regression is an example of a supervised learning. Logistic regression technique that we did is an example of a supervised learning. Classification tree, we had a dichotomous target variable and we are trying to identify the profile of each classes, again a supervised learning. Unsupervised learning technique, the techniques where we do not have a dependent variable, where we have got set of variables and within variables we are trying to analyze and find some relationship, or we are trying to do segmentation. Those are called unsupervised learning techniques. Some of the unsupervised learning techniques are dimension reduction techniques, which are, for example, principal component analysis, factor analysis. I'm not going to cover these two in today's session, but those are dimension reduction techniques. Then we have got clustering. A very simple way to understand clustering is segmentation. Typically when we do segmentation, we go through our understanding of business variables. We take business variables, for example, age, income, and we segment them as high, medium, low. That is a simple example of segmentation. And when we are doing, say, segmentation based on age, high, medium, low, what are we trying to do? We are trying to club 21, 22, 23, 24 together. Say I say 21 to 25 is youth segment. What we are trying to do is we are trying to find ages which are closer to each other, and then we say this is one segment, which means closeness between two data points is a factor we consider when doing segmentation. And the same principle is used in clustering, but at a larger scale. And that's what we are going to see. Okay. And third one is basically association analysis. Simple example, market basket analysis. When we go to a grocery store and when we buy certain set of items together, typically it has been observed that certain set of items go together. Bread and butter or bread with milk. Okay. And there are many such examples where certain set of elements will go together. For example, if you have a party at your house, we'll buy cold drinks, we'll buy chips, and when these quantities are, when chips, cold drinks and these other junk foods are bought together, then a basket of junk foods typically go together. So again, it's a market basket analysis. So it's a association analysis. Of the three main unsupervised learning techniques, out of the dimension reduction, clustering and association, agenda for today is clustering. Yes. And this supervised learning, we already taken 4 different techniques: linear, logistic, random forest. We have already covered classification tree. We have already done. Yeah. Just a quick overview of supervised and unsupervised learning again, so that you remember what these two were. These are certain set of cubes, and there are two main attributes. One is color and second is alphabet. If I ask you to do analysis of this, what you can do is you can say there are red cubes versus green cubes, there are A cubes versus B cubes, or probably you can do a two-dimensional segmentation also saying red and A cube, red and B cube, green and A cube, green and B cube. So you will have four segments. If I add additional information, basically I assign a class label to each of them, lambda and epsilon. And now I say analyze it. What will happen? This will become a supervised learning. And now if you analyze it, a simple rule that you will say is, if color is red, then epsilon. If color is green, then lambda. So now here the entire analysis is with respect to the label where there are two classes, lambda and epsilon, right? This becomes supervised learning. So with that context, we'll go into clustering. But before I go into clustering, I want to share my experience. I've been doing trainings many places, and one of my experience has come is the entire technique was taught, but the why element was not explained. And before I go into clustering, I think so I would like to make that concept clear. Actually, when I'm teaching, the why is explained first, and then the detailing is all what. So why? First, let's understand why. Why data mining? If you recollect, I gave you example of you are doing a marketing campaign and you're working with the chief marketing officer where you are supposed to promote a investment product. And we did the calculation of return on marketing investment. In one of the first, without analytics, if we target 1 million customer, we had a cost of 10 rupees per customer and revenue per convert is 2,500, and incremental conversion was given as 0.5. And I showed you that without analytics, if we target the whole base, we get a 25% return on marketing investment. And if we target only a fraction of the data based upon analytics and segmenting based upon the probability score, red, amber, green, and if we go and target only the green, then we get a return on marketing investment of 225, that is 9x of 25. And why data mining? That is the reason why data mining. By data mining, we are able to get higher return on investment. We are able to get same thing done at a lower cost. Why data mining? Because data mining under the two categories when we have supervised and unsupervised. In a supervised learning technique, a data mining is helping you better classify your customers. Okay, and that is the why aspect, and that is the most important aspect. Why? Now comes how aspect. The how aspect is you have got a data where there are target variable in that case. Basically customer who respond and customer who not respond. Most of the time you will see why most of the techniques are focused around these kind of techniques, because most of the time you will see data is always of that nature where you're trying to analyze whether the event will happen or whether the event will not happen. And to solve that problem, the how element is the techniques. How you can separate the responder class from the non-responder, or the yes class from the no class, or one class from the zero class, you can do using a logistic regression technique, you can do using a classification tree technique, you can do using a random forest, you can do using neural network, you can do using discriminant analysis. That is the how part. Now when we do classification technique, classification technique makes use of algorithm like Jaccard C4.5. And then when I say the Chade technique makes use of chi-square. Now comes, what is chi-square? What is least important? What is least important? The entire explanation of the formula and calculation is one aspect, but the why is the most important. Why are we doing it? And I think so in my entire training I'm trying to stress on the why element, though major part of the time I would be focusing on the what aspect, because that's where the entire detailing is happening. How to compute chi-square, how to see the significance of each variable, how to, based on significance, say which variable is important. So that is how to go about doing the entire model. But if the objective is clear, that why is clear, then you can do a proper what. Similarly, before I go into clustering, let's understand the why aspect. When we do clustering, we have set of independent variables, or set of variables I would say. Now because there is no dependent or independent separation, so I'll say set of variables. Now the point is, if I've got 100 variables and I want to do some modeling, or I want to do, say, let's take example of store segmentation. Many retailers have many store outlets, right? So when they have many store outlets, there will be many attributes for the store. The area, the geography where the store is located, the city tier, the sales, the number of customers they have, the footfalls they get. And once you can create many variables which is related to count, basically number of transaction that happens in the store, you can parallelly create a variable saying total sales of the store. If you can create amount sold and you can create total transaction, you can take a ratio and then create a third variable saying average ticket size, average sale per, average spend per transaction. So now there are many attributes you can create. And again, what you can do is the sales, you can break that sales into department wise sale. What is the sale in apparel? What is the sale in grocery? What is the sale in meat and fish? What is the sale in dairy products? Dairy and frozen products, right? So you can create many variables. Now what happens is you have got many attributes. But when you have got many attributes, which attribute is the most important? Which attribute are similar? Which attributes are similar? You don't know, because now you are flooded with 100 variables, 200 variables. Should you use all 200? Or do you want to reduce and say the important out of the all 200? And that's where dimension reduction techniques comes into play. Now dimension reduction technique, what happens is it reduces the number of variables. But now let's see the other part of it. These sales happen through whom? These sales are done through whom? Customers. So the variables are, there are many variables. When I try to reduce the variable, it is called dimension reduction technique. But now these dimension attributes are created for each and every customer. Now when you try to combine the customers, I hope you are getting, one is reducing the number of variables. Now that is called dimension reduction. Second element is, now for each customer you have got the values corresponding to each of these dimensions. Now when you're trying to combine customers into groups, there is case reduction. Case means record. Case means here record. You are trying to do record reduction. You are trying to group customers in same or other group. You are trying to say this customer belong to this group or the other group. And that is called segmentation or that is called clustering. So our objective is case reduction. How can we group similar set of records in a homogeneous bucket? And that's the entire thing. Why? Now the question is, why do clustering or why segmentation? I've got 1 million customers. I want to do a television ad. When you do a television ad, what do? You convey a message. When you convey a message, whom do you convey a message? To the customers. All to the viewers. All viewers are your customers? Probably no. All viewers are not your customers. Amongst the viewer, there is a segment which is your customer. So the way you design your promotion or the way you design your advertisement is to ensure that your communication is appealing to that segment. Your communication is appealing to that segment. Now you have got million customers. Is million customers million segments for you? No. What you have to do is you have to club these million customers into certain segments or clusters, and then at a cluster level identify what is the underlying theme of them. What is the underlying profile of them, right? So that's where segmentation or clustering comes into play. Basically, reducing millions of records into 5 or 10 segments which are easily understandable, and then use those segment level knowledge for your marketing, promotions, advertisements, or risk management, whatever objective the business may have. That's the broad objective of clustering, or simply put, segmentation. Any questions here? Yeah. So now let's start going into the clustering. I hope the why aspect is very clear. I'm going to make use of certain packages, NB cluster, FPC cluster. So I just put that. Okay. So just like some gyan, where is the life we have lost in living? Where is the wisdom we have lost in knowledge? Where is the knowledge we have lost in information? And where is information? The information is lost in data. We are all talking data, data, data. But at the end of the day, why we want data? From data, we want information. Why we want information? Because from information, we want to get knowledge. Why we want to get knowledge? Because from knowledge, we want to get wisdom. And once you are at a wisdom stage, then what happens is you have what is your business, what is the objective, what everything is very clear. In that case, you don't have to keep going to data again. But yeah, because the scenario keeps changing, you have to keep having this wisdom updated from time to time. Okay, but in the process, what is happening is, in the quest of getting wisdom, we are getting so career oriented that we are losing the entire purpose of life. Okay, so in order to go from data, so basically this is the trajectory. From data we go to information, from information we develop knowledge, and from knowledge we develop wisdom. Let me say it very simply. You are working on a project, say a telecom or a retail or a banking, whatever kind of a project, and you are building a particular kind of a model. And when you're building a particular, you're doing a particular type of analysis. And when you're doing analysis, there are certain data points that you get. Now, 6 months down the line, you get a similar work again. You again start doing from scratch. If you start doing from scratch without recollecting what you did 6 months back, and what knowledge you gained from there, and what wisdom you gained from there, and you don't apply this here, what it does mean? You're just again getting muddled in the data only. Okay, so as you keep working in analytics, numbers and insights, numbers has to become part of your wisdom. Only then subsequent data analysis projects in same vertical, same domain will become easier. Okay, so and in the entire thing, what we are trying to do is, in the entire process, if you have to get to wisdom level, what you have to really do, simplify data, because millions of record cannot be understood, cannot be digested. Millions of records converted into 10 data points as a summary, 10 bullet points as a summary is simple and easy to digest. So in this process, we have to simplify data, and that is clustering. Okay, that is clustering is one of the process way of doing it. Now, how do we simplify data? I already spoken. One is the dimension reduction. You've got many variables, and reducing many variables to a few variable is a simplification process. So that is one way. Second way of simplifying data is you've got millions of record, converting millions of record into 5 to 10 segments is reducing the number of records, and that is another way of simplification. Dimension reduction, what are the various ways of doing it? Dimension reduction you can do using principal component analysis, PCA, you can do using factor analysis, you can do using collinearity matrix, correlation, you can do business rule based also. Okay, so you can do all of that. Clustering or segmentation is, you can do clustering or segmentation by finding similar groups. Let me read this definition. Clustering is reducing the number of records by identifying similar groups and representing them as a cluster. That is clustering process. Okay. So formal definition, clustering is a technique for finding similar groups in data called clusters. The moment you use the word similar, what it means is there you need to have a measure of similarity. If I say two people are similar, then immediately the question would be, how do you say two people are similar? Probably you may say they have got the same level of income, wealth. Probably based on that you said they are similar. Probably you may say they have the same lifestyle. That's why you said they are similar. So you would have identified certain attribute which is matching between the two, and we make them say they are similar. There are many characteristics based on which they would be not similar, but there are certain characteristics the moment we see similar and we make a statement, the entire back of the mind calculation is that attribute in those two personality is matching. So we have to find that. So clustering is a process of finding similarity. Okay. So the next definition, it groups data instances that are similar to bracket near each other in one cluster, and data instances that are different, that is far away from each other, into different clusters. If the data groups are far away from each other, they are grouped into different clusters. The data groups are close to each other based on certain attributes, they are grouped into same cluster. A cluster is therefore a collection of objects which are similar between them and dissimilar to the objects belonging to the other cluster. Now the question is, how do we define similar? So far clear? Yeah. Let's take a simple example. Let's take a simple example. This is basically a survey of shoppers. So basically in a survey of the many questions, two prominent questions were, are you price conscious? or are you brand conscious? And you're supposed to rate yourself as a shopper on a scale of 1 to 10. If I take these two dimensions, and there are certain customers which are marked here, if I take two dimensions and make a plot of these are sample handful of records only, then you see that there are these C, B and E customers, they have rated themselves highly on the price consciousness, and they have rated themselves very low, low or moderate on the brand loyalty, whereas there are other set of customer A and D who have rated themselves very high on the brand aspect and low on the price aspect, right? So if I see this, I can clearly say there are certain customers who are brand conscious, there are certain customers who are price conscious. Probably there would be a third segment also, but here there are few data points which I am trying to explain the concept graphically. There could be a third segment also which would have been brand as well as price conscious, right? Value for money. So they could have that. So there's a simple example. The above data is just a hypothetical data, but there was a survey also done in Chennai of women shoppers. A sample PDF is what I have given. The link to that PDF is given. So probably you can go through that survey data, and they have given their findings based on a k-means technique. Okay, they have said that in the documentation that they have done a clustering using a k-means technique, which we'll go through the technique. Okay. Now, what are the steps involved in clustering? The first and foremost step is formulating the problem. Now, formulating the problem is not a big challenge, but saying what is the objective statement is not a big challenge, but what are the attributes based upon which we are going to go about doing clustering is a big challenge. For example, the same example I can take forward. I want to do clustering of shoppers. I want to do clustering of shoppers. Definitely two pointers I've given you. One is price consciousness and second is brand consciousness. But are these the only two attributes based upon which we can do the clustering of shoppers? Probably no. So there are many other attributes probably. So when we say that formulating the problem, it means deciding the attributes, deciding the parameters which may be important for doing clustering. So deciding that is a task in itself in clustering process. We can take the same example, as I said, store segmentation. I want to do segmentation of, I've got 100 outlets, retail outlets. I want to segment the 100 retail outlets. I can, on a one-dimension space, in a one-dimension space, I can segment them based upon the total sales they generate every month. Some stores would generate 2 crore, some stores would generate 5 crore, some stores would generate 10 crore. Based upon sales, I can segment them. I can segment them based upon the total number of customers, the footfall. I can segment them based upon the margin, because some stores might generate high revenue, but probably they are selling low margin items. There are certain stores which are selling low volume totally, but they are selling high margin products. So deciding the sequence of attributes, the series of attributes which would come important in the entire clustering process is a challenge by itself, and that challenge is left to the person who is doing clustering or the segmentation. Second is, once you have decided the objective and you have decided the attributes, second important challenge that comes into play is which technique to use, hierarchical or non-hierarchical. Simple thumb rule, if you got 100, 150, 200 records, not more than that, then use both hierarchical and non-hierarchical. In hierarchical, the hierarchical clustering technique, we are going to learn agglomerative, use that. And in non-hierarchical, we are going to use k-means clustering, use that, both of them. But if there are huge number of records, say 1000 records, don't even think of doing hierarchical clustering. It's going to take huge amount of time because lots of calculation steps are involved. Now, third basically step is what measure of similarity we have to consider. There are various methodologies which have been proposed. So there is a Euclidean distance, there is a Manhattan distance, there is a Chebyshev distance, and there are a few more. Okay, which distance measure you want to use? The fourth is what algorithm. Now this specifically comes into hierarchical clustering step. We'll see that at a later stage. The fifth is how many clusters you want to create. I've given you store segmentation. 100 stores is what I have said. But of 100 stores, you want to create 3 segments, that is 3 clusters, or whether you want 4 clusters, or whether you want 5 clusters. So deciding how many clusters, how many store segments you want to do is a decision point. Finally, if you have said 3 or 4, if now you have decided that I want to create 4 and you create 4 clusters, you have to see what is the profile of each store, because the entire process you have done and you have got 4 clusters. After you got the 4 clusters, you have to say what is this cluster, how is this cluster different from this, because in the background lots of mathematical calculation has happened and clusters are formed. But that mathematical calculation and then saying, okay, if these are A, B, C, D, 4 clusters, to business you cannot just say, hey, I got this using lots of mathematical calculation and I got 4 clusters. Business want a profile, explanation of how this cluster is separate from this cluster. Make sense? So the profiling is the most important challenge. Final is validating the cluster. So you would do, there are many people who would have lots of practical experience in that particular domain. They are the marketing heads, CFOs, CEOs, and probably they know more detail. So you will have to validate those clusters by talking to senior people and showing them, hey, does it make sense? Practically many people have grounds on feel. Okay, and that's where you have to validate, or probably you will have to experiment. For example, if you're doing segmentation based on market survey data, once you have done segmentation based on market survey data and you have got the market survey information, then you have to validate the clusters. Okay, so that's a quick overview of the how clustering process is done. Any questions so far? Making sense? Yeah. Now let's see formulating the problem, understanding the business problems, and hypothesizing. As I said, most important step in clustering is formulating the variables. Let me take one more example, and probably if you're more interested learning clustering and all those things and practical challenging problem you want to do, I'll take a village affluency categorization example. And this is what many big research firms constantly do. What they do is, what the big research firms constantly do is, they have at a pin code level, they collect pin code level census data. They collect pin code level many other attributes like how many banks are there, how many ATMs are there, how many malls are there, okay, and such other, how far is the airport, how far is the biggest railway junction, how much hours of electricity is available, what is the income level, what are the types of businesses available, right, what is the property value in that area, land value, flat value, and so forth. All these parameters they have, and based upon that, at pin code level, at very granular level, they do lots of analysis where they can say which city, which pin code is more affluent than others. For example, we can, at a top level, we can say Mumbai is the most affluent city, right? But within Mumbai, there are many pin codes where suburbs, where many pin codes which are less affluent. Within a 26, 30 kilometer diameter space of Mumbai, we have many areas where probably you can just make a generic statement, say some big car manufacturer wants to set up in India and they want to open some 100 outlets, showrooms. You cannot just go and say Mumbai, go open. In Mumbai also you will have to say no, whether it should be in Powai or whether it should be in BKC, where it should be. Because they would, if they are coming and they are taking your research, they would like more detailed information. So at that level, they collect many data. And today we have got 1,50,000 pin codes. That data is easily available from Postmaster websites. You can easily download it. You can easily download many information from RBI. You can easily download many information from census. And you have huge, humongous data. And then you come up with some analysis saying which pin codes are affluent, highly affluent, and which pin codes are not affluent. So that can be a challenging program, this thing in itself. And that's what most research firms have, big research firms. Yeah. So getting the concept of formulating element, and believe me, this is the most challenging task in clustering. Running the algorithm is not the challenging task. It's just 5 lines of code. Yeah. Now types of clustering procedures, as I already spoken, there are two main types of clustering procedures: hierarchical, non-hierarchical. In hierarchical, there are two main subcategories: agglomerative and basically divisive. Agglomerative clustering in hierarchical is the most used, and in non-hierarchical, basically k-means is the most used, and these are the two which we'll cover. I'm not going to cover the difference between, first we'll go into the techniques now. Yeah, at a high level, I'll just say hierarchical technique is very slow, non-hierarchical is very fast, and when it comes to doing clustering of huge number of records, go with non-hierarchical technique, which is k-means clustering. Yeah. Hierarchical clustering based on measure of similarity or dissimilarity, and three main measures of similarity or dissimilarities are Euclidean distance, Manhattan distance, and Chebyshev distance. Let us try to understand what this distance. I've now used this word lots. So let's try to understand what this distance is. This is a scale. What is the distance between point A and B? 7. Very clear. So what we did, 28 minus 21, 7. That is a one dimension space. So if I do segmentation based on age, and when I'm grouping 21 to 25, 25 to 30, 32, I'm doing a one dimension segmentation. What if you got two dimensions, age and income? What would you do? Probably we'll do cross tabulation. So we'll say high, medium, low age, assume, and then we'll say high, medium, low income, and we do a cross tabulation, and that process is segmentation. This process we call, this is the slight difference between segmentation and clustering. Segmentation we do based on our intuition. Okay. Segmentation we do based upon our intuition. But if I would have done clustering, instead of doing a segmentation, what I would do is do this one, Pythagoras theorem. Again, I want to convert two dimensions into one dimension, which is distance, and I'll do Pythagoras. Yeah. What do I do if I go from 2 to n dimension? I have got age, I have got income, I have got gender, I have got occupation, I have got variable like qualification, and many other spend parameters, lifestyle parameters, and so forth. That becomes n dimension space. What do you do? Because if you would have done segmentation, max you can go 3 dimensions. Because as a human brain, visually we are able to see 3 dimensions. What we'll do is we'll take 2 dimensions and put the third dimension inside the box. Right? Each cell of the 2 dimensions will put the third dimension and try to relate things. But when the moment it goes from 3 to 4 and 3 to n, our ability shrinks as a human being, normal human being, at least me as a normal human being. So we have to go to, when we go to n dimension space, what we do is the same extension of a Pythagoras theorem, and that formula is called Euclidean distance. Basically, a1 minus b1 the whole square plus a2 minus b2 the whole square plus a3 minus b3 the whole square plus dot 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 an minus bn the whole square. And that's how we compute distance between two records. Yeah. So basically, when I say two records, assume there is a customer 1, age 40, income 50,000, gender male. So I'll say 1, occupation professional, and so forth. Again, I'll have to convert this professional as a numeric because the formula has to apply. It cannot apply on a category. It cannot apply on character. And then there is another customer, age 50, income 60, gender female, occupation professional. So what will happen? 40 minus 50 the whole square plus 50 minus 60 the whole square plus, now it was male and female. So 1 minus 0 the whole squared plus professional was both professional. So this will become into category, say new column professional, and values will be 1 minus 1 the whole square. That's how the formula would work. And that's how whatever is the square root of this calculation will be the distance. Yeah. Depending upon certain scenarios, we may not be able to use this Euclidean distance. There are certain scenarios where you may require certain other formulas. So one other mathematician named Chebyshev proposed a distance logic which says Chebyshev distance, okay, which is also like a chessboard kind of a distance. What it simply says is, I first find distance, there are 4 parameters. So parameter 1 minus parameter, basically customer 1, parameter 1 minus customer 2, parameter 1. That is the distance between. So age 30 and 40, distance is 10. Income 40 and 50, distance is 10. Gender 1 and 0, distance is 1. Professional, distance is 0. Now I got the absolute distances between these two customers. The max of this, any one dimension on which they are max, that is the distance. This is also called as a chessboard distance. If you just think of a chessboard, we have got 64 squares. You got 64 squares. Now distance between two, basically what do you call it, 2 pawns on a chessboard. The way you will see is, you see horizontal distance and you see the vertical distance, and whichever distance is maximum, that distance has to be considered. as a distance. So this is called Chebyshev distance. Yeah. And the final distance is Manhattan distance, also called as a city block distance. Before I go to that, I forgot to make one statement. When to use most of the time, wherever we do customer segmentation, store segmentation, village affluency, those kind of problems, we are going to use Euclidean distance technique. Whenever we have got a survey data where the feedback rating, when data is in ratings feedback 1, 2, 3, 4, 5, we are going to use Chebyshev distance. It is recommended. Okay. And finally, we have got a city block distance, Manhattan distance. What city block Manhattan distance simply says that if I have to move from a block A to a block B, I have to see the actual path that I have to traverse. For example, I have a block A here and there is a block B. And this is say two buildings in a city, in a town. Now if you have to go and there is no road here, if there is no road here, there is no use of having a Pythagoras distance. Does it make sense? So in this case, if this road is like this only, where you have to go from A to this point and then from here to here, if that's the only route available, then that's the distance. There's no point having saying, okay, you are not going to fly from A to B in that case. So there's no point having a Pythagoras. So city block distance or the Manhattan distance used typically in logistic kinds of scenarios, supply chain, logistic, those kind of scenarios, it would be more preferable. However, with these data points given, this kind of a structure given, if I have to find the distance calculation, as a quick example, with the Manhattan distance, the distance would be block 1, 2, 3, 4, and similarly 5, 6, 7, 8, 9, 10, 11, 12. So 8 plus 4, 8 blocks like this, 4 like this, 8 plus 4 is equal to 12 will be my Manhattan distance. If these blocks, I have to compute the distance between block A and B using a Chebyshev distance. So horizontally, what is the distance between horizontal attributes? It's 4 block. Based on the vertical distance, the vertical is 4 and the horizontal is 8. So what is the max out of these? 8. So based upon the Chebyshev distance, my distance would be 8. And if I apply the Euclidean formula, Euclidean would be 4 squared plus 8 squared, square root of that 8.94. Okay. Again, I am repeating, wherever customer segmentation, store segmentation, most of the problem statements that normally we face make use of a Euclidean. Wherever we have got survey data, rating data, feedback data, which is again in rating terms, good, bad, ugly. In that case, you have to go with a Chebyshev data, Chebyshev distance. And when it is a supply chain or practical logistics related problem where distance cannot be in Pythagoras, in that case, go with a city block or the Manhattan distance. Yeah. These are the three main distance measure technique. There are many others. Okay. So, but these are the three main frequently used. That's what I have highlighted. The first thing is how the similarity is computed. Similarity is computed this way. Okay. Now let's try to see with a practical example. Yeah. This is let's before I go into this, as I said, let's try to see with a practical example. Let's take this one. If I want to compute distance between 1 and 2, this is customer 1 and customer 2. If I have to compute the distance, what I'll have to do is 10,000 minus 7,000 the whole square, plus 2 minus 3 the whole square, plus 1 minus 0 the whole square, plus 1 minus 10 the whole square, plus 0 minus 9 the whole square. the addition of all these square terms square root. That would be Euclidean. Similarly, I'll have to compute distance between this and this customer, because you have to first compute distance between each combinations. So you have to then compute distance between this and this. You have to compute distance between this and this. You have to compute distance between this and this and this, and this. But you have to again compute distance between this and this and this. All combinations which are possible have to be done. And whichever is the smallest distance, say assume the distance of C and D of all the combination, all the calculation, the distance calculation between C and D is the least, those two will get combined together. Those two will get combined together into one cluster. So what will happen is, now here I've got 10 records. 10 records will become 9 records. So now with that 9 records, I have to again compute the distance, and whichever is the smallest distance, those combination will get combined together. So in next step I will have 8 records. From 8, again distance between each of them will be computed. 7, 6, 5, 4, 3, 2, 1. So that's a hierarchical clustering. Let me explain this now. At a high level with data, got a high level gist. Okay, so let's try to now understand agglomerative clustering. I know there is one question which is going into mind that I'll explain one slide down the. Okay. Step 1 in a agglomerative clustering or the hierarchical clustering is each record by itself is considered a cluster. I'm again repeating this statement. You got 1 million records, which means you are starting with 1 million segments. Anyways, I already said hierarchical clustering should not be used when you have got 1 million records. So let me reduce this number. You have got 100 stores. Then 100 stores means you have 100 clusters. Each store is considered a cluster of 1. Yeah. Step 2. Sequential, you find the distance for each of the clusters, each of the records. The distance which is the minimum, combine them. So sequentially merge two closest record by distance as a measure of similarity to form a cluster. This reduces the number of records by 1. So I'm starting with 5 clusters in this diagram, and then distance of A with respect to B, C, D, distance of B with A, B, A, C, D, E, distance of C with A, B, D, E, distance of D with A, B, C, E, and distance of E with A, B, C, D is all known. Whichever is the least distance, those two are getting merged. So here I got, say, assume A and B are closest based on distance, and they get merged into one cluster. Sequentially keep doing this step and keep merging records which are closest to each other. So in the next step, probably D and E distance would have come closer. In the next step, probably distance of C with respect to AB or C with respect to DE would have been computed, and that C with DE would have come closest. That's why C got merged with DE, and finally there are these two clusters get merged together to form the total. Okay. Now the key question is here, I've got two objects here. When A and B gets merged, how do I find distance of AB with C? How do I find distance of AB with D? How do I find distance of AB with E? Because there are two records which you have combined. So how do I find distance of AB combination with the individual record C? So long as they were individual record, so long as these are individual record, I have their attributes. But the moment I say, as I said here, C and D is what I get combined. Now, if I want to find distance of this combination with B or with A? Should I take this 7,000 with 10,000 or should I take 6,500 with 10,000? That's a question. Yeah. And this is where linkage algorithms comes into play. This is where linkage algorithms comes into play. So let us try to understand what are linkage algorithms. The single linkage algorithm says that minimum distance or the nearest neighbor rule. For example, I have got cluster 1 and there are two records in this cluster. I have got cluster 2 and I've got two records in this cluster. I'll find distance of this record with this record, so I compute this distance. I find distance of this with respect to this. I find distance of this point with respect to this point, and I find distance of this with respect to this. And of the four distances which are computed here, the distance which is the minimum, is considered to, and that distance is set as the distance between those two clusters, and that is called as simple linkage or the single linkage, where the minimum distance between two record points, one coming from each of the cluster, whichever the minimum is taken. Yeah. The opposite of single linkage is complete linkage, where rather than seeing minimum, you see the maximum. Yeah. The third one is average. Basically, obviously, single and maximum is like taking a decision on one point. It's quite possible one outlier sitting somewhere far. Maximum linkage would definitely get impacted by one outlier sitting far off, and that would spoil the entire cluster. So probably I don't like single linkage, I don't like complete linkage. I like average linkage. So what we'll do, well, first whatever is the data elements in a cluster, for each of them we will find the average, and that average we are going to use, sorry, not the average is not there, for whatever data points in cluster 1 and whatever data points in cluster 2, we'll first compute the distance for each of them. All combination distances will compute, and then take a average of all these distances, and that is called as average linkage. And the fourth element is called centroid linkage. In centroid linkage, what do you do is basically these are the four dots which are part of this cluster. These are the four elements which are part of this cluster. You first compute the centroid of all of them. You compute the centroid. Once you have computed the centroid of this cluster, similarly you compute the centroid of the other cluster and then compute the distance between the centroid. And that is the distance between the two clusters. And the final thing is Ward's distance. Let me read the statement first. Ward method combine clusters with which the increase in within cluster variance is to the smallest degree. Combine clusters with which the increase in within cluster variance is to the smallest degree. What we are trying to do with the entire clustering process? We are trying to find homogeneous set of customers. Why we are trying to find homogeneous? Because they have the similar attributes. Agreed? Now, just theoretically assume there are three clusters. So these are the cluster 1, this is cluster 2, and this is cluster 3. Data always has variance. Agreed? What is variance? The dispersion of data is variance. Simple example, income of all people in the country is not same. Some people income is 10,000, some people income is 1 lakh, and some people is 2.5 lakh a day also, and some people's income is 2.5 crore a year also, a month also, right? So income of all people is not same, and that's why there is a variance. That element is clear, everyone, right? What is variance? Now, if I got these 3 clusters, if I merge this cluster with this cluster, till my iterations were going on, this set was more homogeneous by itself, this was more homogeneous by itself, and this was more homogeneous by itself. Now, moment I merge them, there will be a homogeneity will decrease, because other cluster having certain attributes, I'm agglomerating this. So as I agglomerate and I go to top, as I agglomerate in this, as you go, this will be the most heterogeneous form. This is the most homogeneous because they are cluster of one, and these are relatively less homogeneous than cluster of one. And as you go up, it's an agglomerative process. So in an agglomerative process, as you keep going up, you are trying to combine, and then you become more and more heterogeneous. After seeing this kind of a diagram, you will decide which level we want to stop. Okay, now if I add this cluster 2 to cluster 1, the combination will be slightly more variance, has more variance. Agreed? If I combine this with this 2 and 3, in that case the combination of 2 and 3 will have slightly more variance. If I combine 1 and 3, the combination will have slightly more variance. Now what you have to see is which combination leads to the minimum level of increase in variance. Agreed? When the increase in variance is minimum, which means those two are slightly more equal or homogeneous to each other. And that's the Ward's method. We don't need to go into the entire detailed calculation. Logically, we have to understand, right? So the Ward's method says that as you combine clusters, a combination which leads to minimum increase in the within sum of square, that is x2 minus x hat, the whole squared, or y minus y hat. Variance is what? Y minus the mean, the whole squared, divided by n minus 1, or n if that is the population. That's what variance is. So whichever leads to the minimum increase is to be considered. These are called linkage algorithms. Let me quickly run the hierarchical clustering algorithm. Okay, and before I run the hierarchical clustering algorithm, let me explain what is the data. I'm taking a very simple data. I'm taking some 10 records where there are customers. This is an example from retail. So the data points is basically what is the average spend of the customer, or how many visits they make in a month, which departments they shop, whether they shop in apparel, whether they shop in fruits and vegetables, whether they shop in staples and groceries, which department they are shopping. So these are the various kind of simple data points that I am having. Okay. So these are the 5 variables. At a data level, no issues. Yeah. Now we have to do clustering of these. So what I'm going to do is, as always, I'll first set my working directory. and then I'll import the data. The data which was shown on the screen, the same data is here, 10 records. Okay. Now I want to find distance. So I have to use some distance formula function, and in that function I have to say which distance I want to compute. So here I'm using a distance function. Now distance has to be computed for, I'm saying, third to seventh column. Why? Because I cannot compute distance on name, and I cannot create distance on customer ID. So those two elements are not useful. So third to seventh column is where I have to do. So I'm saying compute distance based on Euclidean. And the moment I say Euclidean, I get this calculation. Let me show that. Okay. So the moment I do that, let me again run this thing. This will come, yeah. So a distance matrix has been computed. So distance of 1 from 2, distance of 1 from 3, 4, and so forth. It's all done. Yeah. So I've done the distance, and now I have to build the model. So I'm going to use hclust. Hclust function documentation is all given here. It's a hierarchical clustering. So D method equal to complete. By default it is complete. I don't want complete. What is complete? Maximum distance. I don't want complete. I want something simple. So I'm going to use average. So I'm saying do the clustering using the distance matrix which we created in the above step, and using a average linkage, and I have done that, and I want to see a plot. This plot is called dendrogram. This plot is called dendrogram. So here I've got the clustering. So here it shows A, B, C, D, E are on one side, F, G, H, I, J are on other side. And this entire data which I set up was intentionally in a particular format, because of which it has come this way. Now let's see what has happened. It has put A, B, C, D, E on one side. 10,000, 7,000, 7,000, 6,500, 6,000. So you can see all of them have got high spend, and rest of them I've got low spends. But if you see A, B, C, D, E on other parameters, are they same on apparel purchase behavior? No. Are they same on FNV purchase behavior? No. There are these 10 times this customer has come, and 12 times this customer has come, and this customer has got good amount of staple and so forth. So in this entire calculation, what has happened is this has dominated the clustering, and intentionally the data was given that way. Let me explain what is happening. The calculation is 10,000 minus 7,000 the whole squared, that is 3,000 the whole squared, plus 2 minus 3 the whole squared, plus 1 minus 0 the whole squared. Now 2 minus 3 the whole squared is what? 1 the whole squared. So 1 the whole squared is 1. 10,000 minus 7,000 the whole squared is what? 3,000 the whole squared, which means 9e raised to 6. 9e raised to 6 plus 1. 2 minus 3 the whole squared. Right? It is 1. Plus 1. 1 minus 0 the whole squared is again 1. Plus 81. 1 minus 10 the whole squared is 81. Plus 81. That 81, 81, 1 and 1, are they going to make any difference to this 9e raised to 6 term? Now the entire calculation when you do square root is what? Square root of 9e raised to 6 only. That is average monthly spend. When you do clustering, you have to scale the variables. You have to scale the variables, because if there is a one particular variable which is very high in scale, that variable will dominate. Agreed? The other way to explain this, which is actually more scientific and right way of understanding. What is the currency of spend? Currency of spend, unit of spend, rupees, any currency, but in India, rupees. So unit of spend is rupees. What is unit of visits? Count. What is unit of apparel items, count of items purchased, count? So the entire calculation is 10,000 minus 7,000 the whole squared. What it is? Rupee squared. Because unit is also getting squared. When I'm using a variable, I'm using also its dimension, which means unit is also part of it. So it becomes rupee square plus count square plus count square plus count square. What mathematics is this? Can you do a rupee square plus count square? Can you add a term which is in rupees and then another term which is in count? So mathematically also you see this don't make sense. What will happen the moment you do standardization, that is scaling of variables? How is scaling done? X minus X bar divided by standard deviation. That is standardization formula, which means for average monthly spend, first I take the average. So assume 5,000. What will be the unit of 5,000? Rupees. What is the formula of standard deviation? X minus X bar the whole square divided by n square root of this term. Rupee minus rupee the whole squared divided by number of records. So there is no unit here. And then square root. So what is the unit again? Rupee. Standard deviation rupee is, and now standardization formula is X minus X bar divided by standard deviation. Rupee minus rupee divided by rupee. Standardized variable becomes unitless. Standardized variable become unitless. Now all of the variables when I standardize, they become unitless, and the moment they become unitless, x minus x bar, x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square plus a2 minus a1 the whole square. There is no unit. I'm just squaring the numbers and then square rooting, so I can do addition of them. So that is the second most important point that you should always remember. Standardizing the variable makes it unitless, right? Once I standardize, I can do all mathematics on it required for clustering. So what I am going to do here, now I already got this output which I know it is wrong, because one variable which is biased or one variable which is high variance, high dispersion, that is influencing the entire clustering, which I don't want. As such, I'm going to standardize my all variables before running clustering. I have standardized my variables. After clustering, the way your variables will look like this. This is how the numbers will look like. These are standardized numbers. So you see, the all thousands have become some fractions. Okay. Now I'm going to compute a distance and then run my clustering and do the plot. Now this time see, earlier A, B, C, D were together. Now only A, C, D is together. B is gone with E, G. And H, I, F, H, F, J has come together. So clearly from this dendrogram, now you have to interpret. Now comes the question, that is, now comes the step, how many clusters to form? How many clusters to form? You have to see this dendrogram and ask yourself, 3 clusters make sense or 4 clusters make sense? Or 5 clusters make sense? It's now up to you as a analyst to decide what the diagram says and decide pictorially whether you feel it's a 2 cluster, it's a 3 cluster, 4 cluster, 5 cluster, or no cluster, 10 all records to be as a separate cluster. So let's assume 3 cluster. Before 3 cluster, let's assume 4 clusters. If I say 4 clusters, what will be the 4 clusters graphically? If you see, what would be that 4 combination? What will be that combination if you ask me? If I ask you. No, 4. If I'm saying 4 clusters to be formed. So what, Hina, what is your answer? A. So basically what you're saying is A will be one cluster, C, D, H, I, F, J will be another cluster, B will be a third cluster, E, G will be a fourth cluster. No, that definitely will not be. Because from here you have to see the CD is closer to A, because if CD would have been closer to HI, this linkage would have happened like this. You have to go with the linkage lines. So HIFJ cannot definitely be part of CD. CD is definitely closer to A at any time compared to HI and FJ.
So I suppose if there are 4 clusters, it would be ACD, HI, FJ, BEG. And if there are 3 clusters, it would be ACD, HI, FJ, and BEG.
So basically, 3 cluster is very clear. 3 cluster is ACD, HIFJ, BEG. 4 cluster is slightly challenging. Okay, so the way you have to do is the distance, again the entire in the back of this thing, there's all calculations of distance of each cluster from other is all available. So let me put the boundaries of these clusters using the function rectangle. Now when you see, these are the 4 clusters. A is a separate cluster, CD is a separate cluster. Now where is this distance? This distance is on this scale. So the distance of CD with respect to A, so somewhere from 1.4 something here till 2.8, 1.4 minus 2.8, the distance is 1.4, and the distance of this HI is somewhere here, and this FJ is somewhere here. So the distance is this much only. So that distance is very less. So that how this on this scale the distance is available in height, and based upon that it is put all these red marks. Okay, but I don't want to go with 4 clusters, so probably I'll say 3 clusters, and then I'll see the 3 clusters. And if I do 3 clusters, this A, C, D is one together. Probably I'll plot this again and then make 3 clusters. So A, C, D, H, I, F, J, B, E, G, these are the 3 clusters. So all this calculation is happening in the background, and that's how you decide the clusters. Okay, my cluster formation is done. Yeah. Now the question is, what is this height? What is this? How is this height? This height is distance actually. Okay. So let me explain this height aspect slightly more in detail.
Before going further, like why are we forming a cluster? Like on what parameters do we form a cluster? I think that is.
Okay. So let me explain this height concept. What is this height? Okay. Before that height, let me show you the distance matrix. After having scaled, we got this distance. What happened? This distance matrix is already come, so I don't have to bother with that warning message. So this is my distance matrix of 1 with respect to 2, 2 with respect to 3, and all this thing. This entire distance matrix nicely I have taken in the Excel, and let me show you that Excel. Instead of labeling them as 1, 2, 3, I've given their names, customer names I have put. Now what has happened? This is the distance matrix. So distance of A with respect to B is 4.25, distance of A with C is 3.41, distance of A with D is 2.51, and so forth. Distance of I with J is 2.06, distance of H with J is 2.12, and so forth. Why are these blanks? Because if I want to find distance of B with respect to C, I can see this way, C with B with respect to C, so I can say B and C. This number is available here, so I don't have to put the above part of the matrix. Of all the distance numbers which are in this selected range, which is the minimum? 0.73 is the minimum. Of all of them, 0.73 is minimum. If you want to know that, is that the minimum? Yes, that's the minimum. So what will happen is, the first is this and this, basically this combination with this combination, these two are going to get merged. Those two will merge first. Zoom. If you see this H and I, of all the lines, all these horizontal lines, if you see, the lowest line is here. And if you draw, if I can probably draw a line parallel from here till here, you will come, it will be 0.7 something only. Okay. Now HI as a cluster with respect to all other dots, it will do the distance using the linkage algorithm that we said, and linkage algorithm we said is average. Probably that distance with respect to others might not have come lowest than some other combination. So now whatever the combinations are forming in that order, I'll explain. Probably the next combination which came was F and J as the least distance. Then other combination that came is probably C and D, and then other combination that came is E and G. At this level, now you assume that this combination made sense. Now I'm trying to explain the height calculation. Okay, internally many calculations are done. Whatever relevant calculation are there, I'm trying to explain. Now when H and HI cluster with Fj is merged, how is this average linkage coming into play? Because we said average. Hi I'm putting here, Fj I'm putting here. What is the distance of H with respect to F? I'll have to come here and see. 2.35. I've taken that 2.35. What is the distance of I with respect to F? I'll have to come from here, 2.18. This is the number I have taken here. What is the distance of H with respect to J? I have to come here and see 2.12. I have taken that number. What is the distance of J with respect to I? So I have to take this J and this I. This is the number 2.06. So I have taken this, and because I have taken average linkage, what does average linkage says? You have to compute all the distances and then take the average, which means I have all these distances already available. I just to take those combination and do averaging, and the average would be 2.17. Likewise, when this CD with respect to all other combination, it would have calculated, and ACD combination works out. So A with respect to C is this much, A with respect to D is this much, 2.96, and this way this entire calculation keeps working. All possible combinations are happening in the background. I'm just showing you the relevant calculation which finally were the least at that level. I'm just showing those things, and this entire calculation worked this way, and this is how I got the total big data set. Can you see this number 3.59? Now let me show you the same numbers here. Cluster height. Okay. 0.72 is the lowest one. Then 1.24, 1.26, 1.40. All these numbers are here. The first level. Yes. And then the next level is 2.17, 2.85, 2.96. 2.96, 2.17, 2.86. Right? And this was 3.06 and 3.59. 3.06 and 3.59. Yes. All other calculations are also done, but at that level, probably this was the minimum. That's why that was given priority for merging of the cluster. This is the entire calculation of this. and based on that it says now this is the dendrogram. Once I have got this, I have now understood the height calculation also. I have also agreed that I want to do 3 cluster. What is the next step? Profiling. Because you have done the clusters, but you don't know what is the attribute. Now if I say ACD is one cluster, what is ACD? What is the profile? Right? I need to now understand what is the profile. So I'll have to do profiling. So what I'm going to do is going to use this cut tree function, and as of now you see there is no column here which says which record A belongs to. Which cluster it belongs to, I don't have that knowledge. So what I'm going to run this step. The moment I run this step, I've put them, this belongs to cluster 1, this belongs to cluster 2, and this belongs to cluster 3. Now I know who belongs to which cluster. Once I know who belongs to which cluster, there's certain set of R code. Now we are not discussing what is code. I'm running some code. I've done some aggregation. No, there's some error. It says aggregation function not found. Cluster profile data frame cluster equal to, this is the same code. There have no changes. Let me run this again. Oh, sorry. I did not run the middle step. One step I skipped. Okay. I've run that step and then this step and then view. So I've got my 3 clusters and the profiling is done. What is profiling? Let's understand what is profiling. Profiling, first understand, many people I've seen that in industry, your boss says that do the profiling of data. And many people confused. What is profiling? Profiling is simple. Continuous variable, get the mean statistics or the median statistics. Get the mean statistics or the median statistics of it. Okay. Categorical variable, get proportion distribution. Say if there is a categorical variable, say gender, and you are set to do profiling. Gender profiling is simple, 70% male, 30% female. The moment you say 70% is male and 30% profiling is on that variable is done. Occupation. If occupation is set, then there are say 5 categories A, B, C, D, E. Take the prominent category out. Say C is prominent and it is 60%. Say C contributes 60% in that segment. Rest of that is contributed by A, B, D, E. If there is some other segment which is more prominent, say D, which is 25%. Say C contributes 60%, D is 25, and the minuscule is left by the other. That is profiling. Okay, so here I've got more continuous variable. So for more continuous variable, I have to go either with the mean statistics or the median. The code is written with respect to the mean. And when I see cluster 1, it says there are 3 records, basically 3 customers belonging to this profile. The average spend of them is 7,833. On average, they visit 4 to 5 times in a month. Are they apparel buyers? They are apparel buyers. Are they FNV buyers? Yes. Are they staple buyer? Yes. So they have at least one item in the apparel from apparel section. They have 2 to 3 items from FNV section and 2 to 3 items from a staple section. That's what their basket is. And because they have a apparel in their basket, their average spend is also on the higher side. Then there is another segment 2. Also there are 3 customers, but their spend is slightly lower than the first segment and the average spend is 5,000 rupees. How many visits they do in a month? Probably 4 to 5 times they come in a month. Whether they go to apparel? No, they don't go. They are heavy spenders on FNV. So which means FNV is what they buy more, fruits and vegetables. But at the same time, they also buy good quantity of staples. And then there is low spend segment where they don't buy apparel, they don't buy expensive fruits. What they buy is what is bare minimum for livelihood basics. Staples is what they buy, consume more. So they spend heavily on staples. Definitely vegetables are required. So some amount of vegetable items are also in their basket. Next important thing is if I have got this cluster 1, 2, 3, I have to jargonize it. Basically, you cannot say cluster 1, cluster 2, cluster 3. You have to give a nomenclature so that within the department, within the organization, now you can refer them. So probably this one where there is a high amount of fruits and vegetables, you may say fruit lovers. I don't know what is the appropriate jargon, but you have to jargonize them, right? So something. So you have to give them. So and that's where segment clustering process will complete. Again, does it give actionable? Yes. Simple. If there is a new apparels that are coming, new designer apparels which are coming, whom would you communicate first? Will you communicate everyone? No. You will send to the apparel buyers segment because last time they came, they bought. So probably targeting them would be more sense compared to others. If there is a season change and because of the season change, new fruit comes in. For example, in summers, mangoes. Now from summer to uh, monsoon, plum, badam, those various fruits will come into on the in the market. When the new fruit comes into market, the early arrivals. When there is an early arrival, you communicate to whom? The fruit lovers. And when there is a grains, definitely you will not say when new grain comes you will not market. Typically, older the rice, better the is. So it all depends upon that. Yeah. So with that, we can say our first technique is completed. Next is non-hierarchical clustering. Yeah. We'll take a break and then do the non-hierarchical clustering. Thank you.